Thank you all very much for being here today to celebrate this milestone in my life. It has not been just a one-person journey. I am supported by a lot of people around me, my family, my friends, my colleagues, and my former colleagues, my supervisors, and my international colleagues, and many of them are also attending here online. So thank you all for spending time with me today. It means a lot to me. Because you have all contributed to my achievements. So thank you very much for that. And I think that the subject of today will be a lot about time. I will talk about time and buildings and time and emissions. And then I'm also very lucky that one of my favorite authors is also here with us today, and he will talk about time and water. So, and maybe I will go a little bit over time compared to what I had planned today, but I think I hope that you will forgive me if I speak a little bit too much today. Sustainability is defined by the three pillars of economy, social, and environment. And all of those three are really important for a sustainable future for us. However, climate urgency, which is one part of the environmental sustainability, it's only a part of the environmental sustainability as such, it is in focus at the moment. Climate scientists have tried to get attention about this subject for many years. The first report from IPCC was published more than 30 years ago. And as we heard, the Danish Building Research Institute was also working with life cycle assessments about this time. But I think that no one has missed the message of the reports of this year. And hopefully humanity will act now. Buildings are an important part of the sustainability of our society. 9% of the global workforce is related to buildings. In our part of the world, we spend about 90% of our time inside buildings, on an average, of course, and 30 to 40% of our environmental impacts are related to buildings. For the climate impacts of buildings, which is the subject I will focus mostly on today, 39% of the global greenhouse gas emissions are related to buildings. So 11% is what we call embodied. That is related to materials that we use for buildings, either to build new buildings or maintain our existing buildings. 28% of the emissions are related to what we call the operation of a building. So when we are heating, cooling, lighting up the building, and so on for the use of the building. So it is important to look into environmental impacts of buildings. Since 2001, I have been working with LCA and developing sector-specific tools for LCA. So during my PhD at DTU, I worked both with development of LCA tool for road construction and also took part in development of a tool for waste management. And then I had a break from academia and I worked as a consultant engineer in Iceland. And there I gained experience with working with those sustainability assessment tools that were getting more attention in the building sector. They are called BREEAM, LEED, GGNB, and so on. And when my family and I decided to move back to Denmark in 2009, I decided that I really wanted to work further with development of those sustainability assessment tools, because my experience from my work with it in Iceland was that it needed a lot of development, and especially the use of LCA in those tools. So I was really, really lucky that I got a job at what was called the Danish Building Research Institute at Aalborg University. And there, since 2009, I have been working with different subjects. both with the sustainability assessment tools for buildings, development of LCA tools, and then also development of the methods that we use to evaluate the environmental impacts of buildings, and of course also several analyses of the environmental impacts of the built environment. So if you look a bit into sustainability assessment of buildings, then my first projects at Build were actually within those sustainability assessment and the establishment of the Green Building Council in Denmark. So first, I was participating with colleagues in the assessment of different possible certification methods that could be used in Denmark. And later, when they had chosen to work with the German system, which is called DGNB, then I was the editor for the adaptation or alignment of the system from German methods to Danish methods, for aligning it to the Danish building sector and needs. And later also, many of my colleagues at Build and we have also been involved in the development of what is called the voluntary sustainability class in Denmark, which is now in a test phase in the building sector. On a European level, we have also participated in testing of European sustainability scheme for buildings, which is new. It's called Levels, and this was tested by about 18 building projects in Denmark. And Build has very often this task of documenting across building cases and so on, and that was what we did, participated with a lot of companies in Denmark to test this European scheme called Levels. And it will be really interesting to follow which role Levels will get in Europe, because we need a transformation of the building sector, and we can see that perhaps Levels will get an important role in the building regulations in the different countries in Europe. And just to conclude on the sustainability assessments of buildings, then I have also been involved in testing 10 different certification methods that are used globally. And what we have tried to look into here is to map what do they include and how large part of the sustainability do they actually assess, because that is really important for the user, the consultants that are out there working with those schemes, that they understand what the target is with those tools that are available. So our research at Build is focused on research to the industry and to academia. And like at all universities, our results, our research results in some academic papers. But maybe, as Per just mentioned, I am not less proud of the research that we do for the industry, because I personally believe that it also benefits the academic research, what we do to transform the industry into more sustainable construction. And here we have developed the Danish national LCA tool for buildings, and we also developed several guidelines for stakeholders in the built environment, as well as research analysis and so on. On March 5th this year, Denmark got a new strategy for sustainable construction. And what was something groundbreaking, but at the time that we have now, it also actually is just so natural, is that there will be now including limit values for greenhouse gas emissions from buildings from 2023. But with this strategy and with those requirements, Denmark is still among very few countries to have requirements and limits values for greenhouse gas emissions for buildings. So how did we get there? How did our research at Build contribute? how can our ongoing research at BUILD contribute to reduce future emissions? And are these requirements that we have, are they meeting the urgent needs for reduction? That will be the topic of this presentation. So for the past 60 years in Denmark, there has been a focus on regulating and bringing down the energy consumption in buildings. And this has been fruitful development, and the requirements are always getting stricter and stricter for the energy use in buildings when you design a building. I know there's a lot to discuss here about the use when the users move into the building, but I will leave that to other people. But this also still brings focus to the whole life cycle of a building, where we both look into the energy consumption of a building, but also the materials that we use in a building. So what we do when we are working with life cycle assessment, we look into the construction of the building materials, the building part on the building side, and then we look into the use states of a building where we have energy use, but we also replace materials, and then there's also the end of life, the waste treatment of the building materials. And since I will be talking a lot about this building life cycle here, and I would just like to explain this a bit more for the people that don't know this just by heart. So the building life cycle is divided into phases and stages, as we see on this table. We had a picture before about the circle, but this is now rolled out in a table. And what we have, the green part, is the phase A. It's focused on the upfront embodied emissions. So when we build the building, the materials that we use, and then also the construction phase, the building site. What follows then are the future scenarios, what happens in the future. So we know that buildings usually have, and hopefully all have, very long life cycles. So this is an important part to look into. But at the same time, we also know and hope that there will be a huge transformation in how we produce materials and how we produce energy and so on. So the future that we're calculating is also very uncertain, but hopefully it will be a green development. So to focus a bit on what I have been working with and my focus in research, I want to start with LCA BUILD, the tool that we talked about. And LCA BUILD has been the core and the focal point of the research in our research group, because it's not only about some kind of a software development that we are working on, because this is the development of a calculations methods as well for how we calculate the CO2 emissions and other environmental impacts from buildings. And at the same time, we are also working on developing a sound simplification of the methods and usability. Because what is our vision here is that we want to mainstream the LCA discipline in the built environment by bringing this practice out from the walls of this university out in practice. So that is what we try to work with, right? Yes. We are all very thankful for the opportunity to work with LCA BUILD, and I would love to talk a bit more about it, but I will leave this subject and talk about method development and simplification and harmonization. And this has been a subject that we have worked with for example, in two extensive international projects, the International Energy Agency Annex 57 and in Annex 72, in Nordic cooperation, and also for national purposes when we are working with developing how we work with LCA for the DGNB certification and now for the requirements in the building regulation. And why do we spend so much time on this? It is because the methods, they matter a lot and they have a lot of influence on our results. And there is a huge focus on harmonization internationally, on European level, on Nordic level. So I will give some examples of my work within this area. So to start with, in Annex 57, one of those international projects I mentioned, we worked on 80 different international case studies, which we gathered and compared with focus on analyzing the differences in methodological differences and the importance of those on the results and needs for harmonization. So the figure here, you remember this phases A, B, and C. You're all experts in this now. A is the production phase, yes? So if we look at the upfront emissions, the emissions that happen now, and we look at these 59 cases that we had there to compare, we can see that the emissions that they report vary from 0 to 1,100 kilogram CO2 per square meter. We know from our research that embodied impacts can vary a lot, but not that much, because this is also explained by differences used in methods how to calculate. And that is why it is so important for us to harmonize methods and find out the ways how to calculate this. So what we actually, this was like in 2017, and a research that was going on starting in 2011, and many other researchers have also worked with this previously. But this is just points out the need for harmonization, which we also have been working a lot on after that. But still what we can bring of results there is that the embodied emissions are growing, and they are important to include. A second thing about method development that I want to focus on is, again, about time. This is not a time management course here, but there is so important to look into timing. And that is something that we in our research group have been focused a lot on. So what we see here now is just an empty scale, but we are looking into time in terms of years, and then we have also the stages that I talked about earlier in a building life cycle. And what is really important for us to try to illustrate this for the people that are working with our tool and understanding our analysis is to explain this on scale, time scale, because what was mentioned earlier is that we have an urgent crisis. Buildings are really important part of the greenhouse gas emissions. Therefore, it's really important for us to focus on what happens now in the near future, because it's in the near future we need to bring the emissions down. And there are also a lot of developments around timing that we are also working on with our research. So this is first, the operational energy use. What we have focused on in our research group and in the tool of LCA BUILD and in our method is that we want to use something that is called dynamic approach for calculating the future, take into account how the future emissions of the energy production will change over time, because there are a lot of political agreements about changing the energy production over time. So that is included in our calculation method. And also to show the importance of embodied impacts. What this shows is just for a random building, where we can see when we build this building, we have, in this particular case, a reasonable high amount of CO2 emissions that happen in year 0 when we build the building. And then we need to realize that we are changing windows and we have to change materials over time, and that's why they will increase over time. So this is something that we have worked a lot on in our research group to include in our calculations. And that is why also there are not all other countries that are doing it this way. So here again, there are methods, they are different, but I think that many countries around us are making the same assumptions or considering that. But it is also so important to look into time. If this was another building that has much higher emissions in the beginning, or another case where the emissions are low now, and so on, it is really important for us to take into account. And why all this focus on time? Yeah, in Denmark, there's a focus on and political agreements on reduction of the emissions of greenhouse gases with 70% in 2030 compared to 1990. And in Europe, there are goals of having a climate-neutral society in 2050. We're talking about 30 years from now. And the IPCC reports that show us that there is a need to reduce emissions as fast as possible. You know, and that Pierre also mentioned, as fast as possible to be able to meet our agreements to reduce our emissions. Next topic. I want to focus a bit on the embodied impacts, how we calculate whole life carbon or life cycle assessment of buildings for new constructions. So for the next 5 or 10 minutes or so, I'm going to tell you a bit about our research within this topic. And I will focus on both some national study that we have done in Denmark and also in an international perspective, and also some European ongoing projects. So first, one important report and study that we have been working on was this whole life carbon assessment of 60 building cases, which was published in Danish in 2020 and also translated to English due to requests from the European Commission in order, So this report was done, about 1.5 or 2 years ago. We have been working on this. But the purpose was to establish sufficient data background on the climate impact of building in Denmark over the life cycle, and also on basis of this to calculate possible reference values that could be used in the building sector. And just to go quickly into the results, so these are the 60 buildings, each bar is one building. And this is their whole life cycle, and it is divided into materials, the greener part, and bluer part, or gray, is the operational energy. I hope you can see the difference. What you can see here is that the emissions, they vary from 6 to about 14, so there's quite a difference there. And if we take the average based on the methods that we use here in the design phase of a building to calculate both the material use and the energy use, then about 1/4, 25% about, of the emissions over 50 years is from operational energy, and 3/4 are from the materials. And you remember that this is something that has not been regulated yet, the use of materials when you construct a new building. But this was the groundbreaking part that is happening in 1 year, 1.5 or something, And important lessons learned from this study was the importance of embodied impacts. They are important, about these around 25% often in building cases. Secondly, the timing of emissions are important. When do they happen? Over time. That is important. And if we look into the results, then when we calculate the whole life carbon, both the energy and the materials, then the results vary a lot, about factor of 2.2. And if we look into the embodied impacts, the materials that we are not regulating, have not been regulating, then this varies from 3.7 here to 10.8. So this is about 3 times. So this must tell us that there is a huge potential to do some reductions, because if we can build some acceptable buildings with about 2 to 3 times lower greenhouse gas emissions, then there must be a potential for many of the other buildings to follow this. So, where have those results been used? In Denmark, the government, they had climate partnerships, so cooperation with the industry and different partnerships. So one of, I think, about 13 partnerships they established in 2019 and 20. One of them was focusing on the construction industry. And this partnership of the construction industry also used the results of our study to suggest, this was in like March 2020, to suggest the government that we should have requirements for LCA CO2 requirements in the building regulation in 2021. And this is of 12 kilograms CO2 per square meter per year based on our results. And then we should also have an incentive for the industry to work with even lower requirements. So we have this voluntary sustainability class to try to have some competition here. So, and then also important for the industry to know the future requirements to come. So in 10 years to come, it should be, you should know that we should halve the emissions, going from 12 to 6. And just if you look at, this is again our cases. So the building regulation, what was suggested is, okay, we have to have everybody on board, work with LCA and so on, and the requirements might not seem that strict, but people working with this know also that, this is a totally new discipline for the building sector to work with, so it can be discussed. And then the voluntary class should be among the lowest buildings. And what we should know is that in 10 years, then all like normal buildings, they should be around the best buildings that we know today, and the best buildings, we need to figure out different ways how to build those. So they should be here around 3.5 to 4 kilograms CO2. And this, is something that needs a lot of new ways of thinking in the building sector. And then the new national strategy that I also mentioned that came in March 21, they also had those requirements, like followed up on what came from the climate partnerships. So we have both a building regulation requirement and a voluntary class, and they also know what will be the requirements in 10 years about. And just to see, this is in the same area of ambition levels as was proposed by the climate partnerships. So if you look then from a national perspective, where they have used our research to look a bit into international perspective. And here again, I come to the Annex 57 project that I mentioned earlier, where we again looked into those 80 buildings. And here, the conclusion for our cooperation, international cooperation, there was that embodied impacts, they are important, but all about this, the methodological harmonization needs that I mentioned earlier, that is really important. And a second project that we have been working on, the other international project, the Annex 72, in relation to that, a group of people from that project were also working together, several researchers from different countries. And here we were analyzing 650, I think, if I remember correctly, building cases that we were working with, analyzing those. And what the conclusion, and what we, what we concluded there by looking into several international studies, that although we know that those methods are a bit different, we try to align our analysis so we could compare as well as possible. But the bottom line here was the message that embodied impacts, the materials, are really important to include in regulation, and that, as here, embodied greenhouse gas emissions, they might actually be the hidden challenge for effective climate change mitigation. And also another figure from our project, and I know it maybe might be complicated for many, and I am not going to go totally into details with this, but what is important here is there is this carbon spike, what I talked about in the beginning, So when we build a building, there's a huge responsibility because we showed earlier that you can build one building about 3 times compared to the other ones. So there's a huge responsibility here in order to try to build a robust and good building, but take care of the emissions that we have in the beginning. And what is secondly important to look into, when do we have this break even between materials and operation? Then, so if we calculate what we call a static approach, so we assume that we produce energy and heating and cooling, electricity and heating today for the next 50 years at the same time, which is pretty unrealistic, then this break even will be in 35 years. If we take into account this dynamic approach that I introduced to you earlier, then this break even will be after 50 years. And so for new buildings, it's really important to focus on the materials. And then a European project, I just want to mention very quickly, ongoing project that we are working together with Rambøll and some research colleagues, is a project where there is this need, again, for this European harmonized benchmarks. I've talked a lot about harmonization, but there is a need for that because we have different European policies and initiatives going on right now that need those benchmarks. And it's really important that we try to figure out how long is a meter? How much kilograms CO2 is it from a building? And here we are working together in 5 different countries to align our methods, and then it is the proposal to be able to show how we can do it in the other European countries. But also what we want to do is to take into account those, what we have done earlier is often to look into how did we build and how can we reduce a bit, always depending on how we built yesterday, and reduce a bit better. But what if we look into the real climate budget that we have? What is then what is then our benchmark if we look into what do we have actually to work with? And that is one of the things that we are working with in this project. So there is no doubt that we need to reduce climate impacts related to buildings, but what do we have in our toolbox? So again, from the Annex 57, we looked into different design strategies and compared reduction strategy, how much you can reduce with different design strategies. And there are a lot of potentials there. And what I want to bring into focus are just 2, if you call it a design strategy, that we have been working with in research projects at BUILD. So one is about circular strategies and one is about increased use of wood in building. I could, of course, mention many more, but I will focus on that. So first, use of biogenic materials, increased use of wood in buildings. And if we go to the study that I've presented for you earlier about the 60 building cases, then we looked into, okay, the buildings from those 60 buildings that had structural elements of wood, where are they in the scale? So we can see here, you can see it here, that many of the wooden buildings are in the lower scale. But we have also some buildings up there. So the conclusion is, of course, a quick conclusion now, but the conclusion is, well, it is not enough to just say we should use wooden buildings and then everything is fixed. Because we can also make then some unclever decisions about the roofing material or the foundation or whatever. So again, the use of our LCA tool is really important to make sure that we continue with the clever decisions to keep the result in the lower end. And, well, there are several studies that have, not just this study that I showed earlier, but several international studies that suggest that wood in buildings can help to reduce the climate impacts. And that is why we have a larger research project on this. And we have just published a study where we examined 79 scientific articles were focused on like 226 cases working with that were using wood in buildings. And again, maybe a complicated figure, but the first three here are residential and single-family houses, residential multifamily houses, and offices that we are working with. And what we compare them with here are the average from our, if you remember the study about the 650 building cases that we worked on. So there we can see that when we look into what has been worked in academia, there is a huge potential, or there is a potential, and there is a potential to reduce the climate impacts if we are using wood in building in a clever way. And we are also looking into use of wood in buildings in different perspectives, not just because what I mentioned earlier, what are our goals to reduce in the urgent future, but also there's something about this time scale and some properties of wood that we are working on. So timing of our emissions is really important. Greenhouse gas emissions, they accumulate in the atmosphere, and the sooner the emissions occur, they have longer time to accumulate there. So larger potential for global warming when this happens, if it happens early. But there's also something about wood what is really important for us to look into, because when trees are growing, they absorb CO2 from the environment or from the atmosphere. And if this is used in buildings, it might be stored there, and then at some point in future, not just when it is combusted, but also when it is degraded, this CO2 might or will at some point be released to the atmosphere. But what many researchers and the building industry is looking into is how large is this potential? How much will this save us, if we store more wood or timber in buildings? And here again, we know that dynamic LCA modeling is important to look into this timing. And again, we do things in a different way. So now I have just Denmark and Sweden, the neighboring countries, just to illustrate how we calculate this. So in Denmark, as in many other countries, now it's not just a Danish way of doing, but then we allow to take this uptake of CO2 in the wood in our calculation, so we can see that in our time scale, there is a potential of this is an extreme good case, but they might differ, that there might be a potential. And then in the end, at some point, maybe, hopefully not after 50 years, hopefully in much longer time, this might be released again. But we need to take that into account because this might happen or will happen at some point. But in Sweden, they have, or in other countries as well, the wood is like regarded as CO2 neutral, so we don't take this minus trip into account, but we have the same results in the end. But this is something that we really want to work further with the building sector to find out when does this the CO2 uptake happen, because that is really important for us if we have to reduce, or it's not if, since we have to reduce a lot in the next decade, and by 2050 CO2 neutral, it's really important for us to understand this. And that is what we are what we are working with in an ongoing research projects, where we are looking into dynamic modeling of this, and when do we really have this uptake? How much will it help us in the fixing our problems? Yes. Very quickly about circular strategies. There's a lot of focus on circular economy, recycling, reuse. How can we work with that? And we need to know what is the potential here also, And of course, reusing materials and different other circular strategies, of course, we know in a resource perspective, there is a potential, but now I'm focusing a lot on CO2 perspective. And this is, again, relates to a PhD study performed by Leonora, where we can show, okay, looking into literature and practice, many circular strategies exist. In my point of view, many of the circular strategies that we are talking about here are actually also what we just called as eco-design and so on. But now they are here defined by circular strategies. But what is the real benefit? That is really important for us to look into. And again, my time management course here today, what we need to look into is when do we really have those, reductions? Because we might have many good intentions to work with circular strategies, and I'm sure that in most cases it is good, but if we are focusing on CO2 and we think that we can solve our climate problems with circular strategies, we need to look into when does it happen. So if you focus on upcycling, upcycling is like recycling, and there the effects happen when we build the building. Then different circular strategies exist, and if you look into, there is a lot of focus now on reusing bricks in building, reuse, for example, crushed concrete in new concrete, and reuse, for example, of window glass. So if you just look at those and what we have done in some studies, then we can see reused bricks. It has a quite high potential to reduce compared to virgin materials. So that is a good strategy to work with in terms of CO2 and in terms of the amount of reused bricks we have available. If you look into recycled concrete, it is a good strategy in a resource perspective and so on, but when we look into CO2, then not that much savings, and not necessarily savings will happen. But again, then reusing glass, if that is possible, and it fits into, if it is possible to use this old glass in new windows, then there is a quite high also potential there. And then what we have been looking also into, and what Leonora and Leonora has been working on, and Freya in her PhD studies, is this design for disassembly. And that is where we produce materials today, and we think about that we want to make them today that good that they can be reused in future. And that is, of course, very important for us. But we have to keep in mind that this will give us some savings later on. But here, Leonora has worked on, in her PhD, to look into, okay, if we want to do this and what we want to do, how can we calculate this, and how can we divide the emissions that happen when, or should we do that, to divide the emissions that we have when we produce materials, for example here, a concrete beam that perhaps can be reused again. And finally, I cannot leave this traveling around the buildings without mentioning just a little bit about existing buildings. So you are now all experts in this drawing. This is the new construction, emissions, and when, timing, and when this happened. What happens. But if we look into existing buildings and maybe old buildings, then their lines, their figures are a bit different. Many old buildings have high operational energy, but if you're just maintaining them as usual, then they might just have low embodied impacts over time. We want to focus on renovation today. There's a huge focus on renovation of existing buildings in order to bring this energy consumption down, and that is no question that is something that we need to do. And then what we have to keep in mind is that we are using materials, so there will be some embodied emissions, like used, if we can say so, in order to bring the energy consumption down. But what we know is that there might be used very different methods for those, and many different materials exist. So as we had showed you earlier, that you can also build buildings with different methods, then this is also important to take into account the embodied emissions that we are spending in order to bring down the energy consumption. So I am slightly getting there, and I want to talk a bit on urgency. Maybe you think I have been talking on urgency all the time, but I want to focus on that. So we in Denmark, we have the Earth Overshoot Day on March 26. So that means that in Denmark, we need about 4 globes or Earths for our current consumption. And we know that we don't have that available. And in order to work with this, then the emissions are also quite high. So, and we have these requirements in Denmark for CO2 emissions, and are they then meeting the need for reduction? And what we have, when we have set those benchmarks, for example, this one of 12 kilograms CO2 per square meter per year, then that is based on something that we call a bottom-up approach. It is based on experiences that we get on how we build buildings and say, okay, we're trying to do always better and better. But if we go to something that is called the top-down approach, this is focusing on what is our budget and what is then my benchmark. That is something that we also need to look into in our research. So that is something about carbon budgets that we are working on together with many international researchers on the focus on those budgets and focus on planetary boundaries, which says when we are using more than what is available with only one Earth available. So there we have had, I have been so lucky to be like involved in different projects. So here I'm highlighting the people that have been really working on it. So master project of Pernille and Camilla, and where I, together with many others, have been supervisor. And here we've been looking into, okay, how are we building our buildings? These are the mini CO2 houses, which should be then a good, which are good examples. But how are they meeting our absolute sustainability? And here, just to go quickly into the results of those different houses, the reference house and the upcycle house and so on, they are about 5 to 10 times higher than, the absolute, what should be absolute sustainable. This should be here if we are supposed to be assuming we have one Earth available. If you just say it, simplify it a bit. And I also want to highlight ongoing research, also another PhD student, Lise at Rambøll, where I'm also just among many supervisors. But there's, we are also looking into the top-down approach for looking into the CO2 limits if we have, looking into the budgets that we have to meet the Paris Agreement. So I will not go into details of this, but we have different methods to calculate and estimate, or Lisa is working on it, to estimate then what is our budget if taking this into account. And here we have, these are the requirements that we have now. We had to change a bit of, and we had to model them a little bit, but these are the requirements that I have told you about, this 12 kilograms CO2 calculated into some different units, but in the legislation, and this is the voluntary sustainability class, if we look into years. And then, according to her calculations here, how does it then look like? So these are the first calculations that Lisa has been working with about, what is our budget when we look into terms of the Paris Agreement? And where are our requirements that we are having here? Okay, we can look at from one perspective, seeing. this is really bad. We are twice as high, and also in 10 years, we are still very far from the budget. And I have to say that these calculations are still estimations, but they're good guesstimates that we have. But we could also look at it from another point of view of saying, you know, I would like to rather like to spend my next 10 years thinking the glass is half full and saying, okay, if we get as many as possible on board on the voluntary sustainability class, then in 2029, and if we can manage to work this way, then we are not that far away. So it might show us that we also have good possibility. But it is, you know, it is definitely, there is no doubt that we need everyone in this value chain, the stakeholders, to take action in finding the ways how we can produce materials to meet this, how we can design buildings differently, and maybe we also need to think about our needs ourselves, about our requirements for space and things like that. Yes. My future visions. I think I will allow myself to be a bit emotional and ambitious today. So if I cannot do it today, when can I do it? So this is the day. So my dream is that my research, together with all the people I work with, nationally and internationally in our research group, that we can contribute in solving the climate challenges in the building sector. And again, this will require a hell of a cooperation, and it will need all stakeholders to come on board. So this is a very challenging task. And if I get a bit more precise about this, then I also know that the national strategy that we have, and I am not the only one working on the strategy, there are a lot of people here in the room and online and so on, you know, working on it. But we know that there is a lot of needs for research to work with. So I think the vision for me and our research group is also, you know, set by this strategy. We know what to do for the next 10 years, to look into existing buildings and new buildings and our tools and harmonization. So I'll not go more into details of that. And also for us to work with like a roadmap development for the Danish building sector to find solutions for how we can reduce in 2030 and in 2050 with different strategies, and look into the timing. For teaching, my vision is that all students at universities in Denmark, not in Aalborg University, they should have a minimum knowledge of LCA in the built environment. So when you are a building engineer, civil engineer, it's our responsibility that you know a little bit about the emissions and the decisions that you have, but also that we need a large part of, and we need a big part of the students that have a deep knowledge about LCA. And what the Danish building sector needs to understand is that also that we cannot, the universities cannot provide us with enough students in the near future, new students, to solve this. So we need to have, you know, a lot of focus on continuing education for the people that are working already out there. And this cannot be covered by like 1 or 2 days courses. This is a bigger education that we need. There's a new discipline here to work with, and we need to realize that. So here, my academic part of my lecture ends, and I would like to make some link to my guest, Andrés Nair Magnusson, who is, I wrote it in on LinkedIn that I asked him in 2009 to give a wake-up call lecture when I stopped working in my beloved engineering company in Iceland. So instead of baking a cake, I'm sorry, there has been discussion in Denmark about cakes, but I did not make a cake. But I asked him to give a lecture, and I was really happy that he did so. But I asked him again to give some kind of a wake-up call also here today, so I'm really happy for that. But inspired by his book, I want to bring a history. So, what do we see here? Private story. In Andrés Magnusson's book, his grandmother is mentioned a lot. And me and Andre, we are very lucky that we both have very old grandmothers. My grandmother is 96, and his grandmother is 97. And mine is born in 1925, and yeah, so she's 96 years today. On the picture, you can see my 3 kids, and they are born in 2007, 13, and 17. The youngest one has not arrived yet to here. She will be here later. But they can be 96 years old in 2103, 2109, and 2113, if they are lucky to be as healthy as my grandmother. So, all these figures about time and our emissions, and what happens now, and their effects on our future, they are relevant for us. And the IPCC has 5 different scenarios for the future, and what was mentioned earlier is that we need to stay on the blue line here if we want to stay below 1.5 or 2.0 degrees. But this is not the track we are going on at the moment. We need to have urgent changes if we want to be there. So this will mean that these are showing us the differences in temperature rise if we follow the different pathways that are given. And this is showing us, how our future will be in terms of the Arctic Sea ice area. So if only the blue lines here will secure that we will have some ice in the Arctic areas in 2100. And then there's also different scenarios for the sea rise level. So to conclude, which scenarios are we aiming for us and our future generations? And we still have a choice, but we need to have urgent actions. Thank you.